Okay, so let's start first with the word file. Yung structural forms, no? I have identified here 4 structural forms, and I would like to know how to interpret yung regression outputs kung yung model natin, yung form ng model natin follows a particular format. Okay, alam natin to guys, yung lean log, we know this already kasi ito usually yung model natin na ginagawa. Linear sa Y, linear din sa X, sa lahat ng X's, sa mga ano natin, sa mga independent variables natin. So how do you interpret that? We know that for every 1 unit change in X, there's a corresponding B1.
Sir?
Yes?
Wala ka pong pinapakita sa screen.
Ay, sorry. Wala ba? Thank you. Wala. Hindi ko pa na-share. Sorry. And can you see now? Guys?
Yes, sir.
All right.
Yes, sir.
Yes, sir.
Yes,
Okay,
sir.
so thank you. 4 na forms guys yung titingnan natin. Lean log, log lean, at saka log log. No? Yung una guys, we know this already. I won't discuss this anymore. Sabi natin, pag lean yung model natin, for every 1 unit change in X, there's a corresponding B1 units change in Y. Yun lang yun, no? Ceteris paribus, of course. So we know that if you change X by 1, we'd expect Y to change by B1 units. X will change by 1 unit, dapat 1 unit to. Y will change by B1 units din dapat to. Parehong units dapat yan. All right. Let's go here guys, yung log. Okay. This is what you call the log-log regression or double log, or others call this log linear. Pareho din yun. Log linear. Hindi siya log lean, ha? Okay, iba yung log lean. Ito yung log lean. Ito log linear. Okay, how do we interpret this? Pag lahat ng mga independent variables natin nakalog, tapos si Y natin nakalog din, and that's called your log-log, double log, or log linear model. Now, how do you interpret this? For example, ito, si B1 na to. Ano ibig sabihin ito? Okay, ang interpretation yan, for every, okay, let me just engage my, naka-8 na ako. Bakit baliktad to? Baliktad yung baliktad. Okay. Dalang ha. Okay, so for every 1%, take note, I didn't use units. Pag log-log guys, ang interpretation yan, percent, no? 1% change in X. There's a corresponding beta 1% change in Y. Okay? Take note guys, panay mga percent. Percent change in X, percent change in Y. Okay? Log. Of course, may ceteris paribus pa rin. Kung meron pa tayong ibang kung we still have other independent variables na nakalog pa rin. Any questions, guys? Any questions? Hello?
None, sir, none.
Wala. So, kunyari guys, kunyari log wage, kunyari, is equal to maybe 0 dito plus, let's say, 0.28 log, natin log salary, kunyari, ha? Okay. How do we now interpret that? That's error term. How do we interpret this, guys? for every, kasi panay log siya guys, so this is log. For every 1% change in log salary, what happens guys? There's a corresponding 0.28% change in log wage. You follow guys? Kinapilan natin yung beta 1 na yan. Ito. Eksakto kung ano nakalagay dyan, yun. Tapos lalagyan na natin ng percent. Okay. So next guys, tingnan natin si lean log. Ano naman si lean log? Linear or level. Level sa Y, log sa X. Okay? So yung kanina, kunyari wage is equal to beta null plus beta 1 times 0.2 pa rin, 0.28 log salary. Example lang yan. May wage na may salary pa. Okay, what does that mean guys? How do we interpret this? Okay, kung sino man yung nakalog guys, laging ang ano niya, ang pagbasa niya percent. Okay, so since si X nakalog siya, so ang pagbasa natin yan for every 1% change in log salary, ano daw? There is a corresponding, okay, beta 1 over 100 units change in wage. Okay, you follow guys? Okay. May baka may importanteng shot to. Adrian, okay lang kasi hindi naman ako nag-check ng attendance na. Okay. Thank you, Adrian. Okay, so saan na tayo? Clear yan guys? Lean log, guys. Yung linear, lagi siyang units ang pagbasa, ha? Yung log, laging percent yan. Okay? Kaya kanina yung log, panay percent. Hindi natin linalagyan ng units. Pero pag linear, laging may units. Okay? Si lean ba, pag linear, pwede may percent din? Pwede. Basta, laging may units. No? For example, ito. For every 1% change in log salary, there's a corresponding beta 1 over 100 units change in wage ceteris paribus. Or this can be read as what, guys? As for every 1% change in log salary, there's a corresponding what? Beta 1%. No? Kasi itong beta 1 over 100, that's beta 1%. Eh. Units pa rin, no? Units change in wage. Clear? Clear, guys?
Yes, sir. Clear.
Okay. Next, guys. Si log lean naman. Log linear. Log lean. Kasi log linear, si double log yon. So we call this log lean. Hindi log linear, ha? Log lean, tapos or we call it also log level. Okay, so paano to? Again, guys, may clue naman tayo eh. Log level. So ito level to, dapat ano to, units, no? So for every 1 unit change in X, okay, there's a corresponding ito, si log. Pag ganyan guys, si log yung si Y yung nakalog, si X hindi nakalog, level siya. May percent pa rin to, kaso mangyayari na beta 1, 100 times beta 1 na. Okay? I-multiply na natin ng 100. Okay, so bakit ganon? I'm sorry, we cannot, wala na tayong time para ma-discuss yan. Pero it has something to do just with yung proportions nila. No? So it's actually easy to prove. Pero just remember that, guys. Ang importante naman sa atin kung paano natin i-interpret. We don't need to derive or to prove that ganun nga yung pagbasa niyan. But ganun ang pagbasa, guys. So summarize natin. Pag log, guys, Pag log, paano? Pag log, 1% change in X will yield beta 1% change in Y. Okay? Pag lin, 1 unit change in X will result to B1 units change in Y. Ganun lang. Pag lin log naman, take note, ang nakalog si X. So naka-percent dapat yung pagbasa natin dyan. For every 1% change in X, there's a corresponding B1 over 100 units. Okay, may units change in Y. And then lastly, for log lin, take note, ang naka-log is si Y, so ipe-percent natin yan. Si X, since naka-linear siya, units ang basa niyan. So for every 1 unit change in X, there is a corresponding 100 times beta 1% change in Y. Percent, guys, percent, no? Percent. Yan, 100 times beta 1, may percent change in Y. Okay, bakit ganun? Ganyan yung rule, guys, no? Ganyan yung rule. Okay, so that's yung structural forms. Pag nakamit kayo ng mga models o kunyari may model kayo na, may minomodel kayo na ganyan yung form niya, then you should know how to interpret the model based on these guidelines. Okay, any questions? Any questions, guys?
None po, sir.
Thank you. Okay, let's go to our R. Pakibukas yung R, guys. Make sure na require na, ready na for you si Broom, si car plot, lahat ng mga to. Okay. Si Gigi Ali yata hindi yata natin nagamit ngayon. Stargazer nagamit, LM test, Gigi plot 2. Okay, most of this. Alright, I think na ano ko na to. Okay, and then when you have uploaded those, paki-import na si OLK. I already have OLK, guys. Ito na yung ginamit ko kanina. So, iba lang tayo ng OLK, guys, kasi yung sa akin may mga log, no? If you're just importing it for just today, so dapat tatlo lang to. Output, labor, capital. Wala ito. Ito yung ginawa natin last time. Okay, you follow, guys? Ano na ba? Na-import na si OLK, output, labor, capital?
Yes, coach.
All right, thank you. Now let's go here. Yung unang titingnan natin, guys, is we discussed this a while ago, si log-log, double log, or log linear. Okay, you have a very famous function, formula, economic relationship in ECO, relationship in economics. No? Si Cobb-Douglas. Have you discussed this? Na-discuss nyo ba sa ECO nyo to, guys? Anyone?
No.
No, hindi nyo. First time yung narinig. Okay. Si
We don't recall,
Cobb-Douglas.
sir.
Sorry? Sorry? Who was that? Ano sabi?
Don't recall po.
Don't recall. Okay. Sige. Thank you. Thank you. Okay. Si Cobb-Douglas, guys, it relates output. Q is output, labor, and capital. No? So, sinasabi dito sa Cobb-Douglas form na to, na this is one form of Cobb-Douglas, may iba pa. Ang sinasabi niyan, output is related to labor and capital. So, the more labor you input or the more capital, mas malaki din yung output, no? Makes sense naman, no? Makes sense na pag mas maraming labor ang pinasok, mas maraming capital ang pinasok, mas expecting na dapat mas malaki yung output. Okay, balik lang ako dun sa sa word natin. Balikan ko lang to ng konti. Okay, ang problema natin sa model na yan. Okay, stop thinking muna ako. Hirap matanggal ah. Tanggalin ko naman. Erase lang. Okay, so let me just rewrite here the Cobb-Douglas function. So sabi dun sa Cobb-Douglas function, so this is the Cobb-Douglas function. Sabi, output daw is equal to a certain constant B1 times labor raised to a constant B2 times capital raised to a certain constant B3. Okay, take a look at that, guys. So meron tayong data na given a certain output, given labor and capital, ito yung corresponding output. Yun yung sa OLK natin, guys, OLK. No? Pero ang problema natin, can we regress? Based on this equation, can we perform regression? The answer is no, guys. Hindi pa pwede. Bakit? Hindi linear yung mga parameters natin. Yan, si B2 naka-exponentiate siya. Yan. So, hindi pwedeng OLS to. Hindi pwedeng regression, yung multiple regression, kasi ang basis niya, yung ordinary least squares, ang isa sa assumption nun, kailangan linear in the parameters. So how do we address this? If I want to develop a regression model relating output with labor and capital, I can't possibly use this. No? Kasi nga, hindi nakalinear yung mga parameters natin. Unless I do something. So what we can do is to do a mathematical transformation, get the logs of each. Okay. Now, if you recall in your high school math, ano ba yung log of a product? Log of the product, guys, is the sum of the log of the factors. No? So ito multiplication to, ito multiplication to. So mako-convert yung multiplication into addition plus log Li to the B2 plus log Ki to the B3. Okay, so that's our converted equation. So ngayon, anong next step? We can simplify this further using the laws of logarithm. This is log B1 plus, okay, ano mangyayari sa exponent na to? Bababa, di ba? Kasi yun yung rule ng logarithm eh. B1 times log labor I sub I plus B3 times log of K sub I. Yan. Okay? Can we now regress this, guys? Pwede na. Kasi yung B1 natin, linear na siya, no? Okay? It's just B1 times a certain variable. The log of the variable. Okay, follow, guys? Follow?
Yes, sir.
Okay. So last step, ito, log Q sub I, let's call this our equation number 1. Log Q sub I is equal to, itong log B1 na to, di ba si B1 constant to? Kasi intercept to eh. Okay, whatever value this is, it's a constant. No? So pwede nating i-replace na lang si log B1 ng a certain variable, A na lang. A plus B1 log of L labor plus B2 plus B3 log of capital. Okay, so this is our equation number 1. Now, can we do regression now for this one? Pwede na, guys. And it will take the structural form log. Diba? Kasi yung dependent variable natin nakalog, yung independent variables natin lahat, guys, siyempre hindi kasama itong si A. No? Lahat ng independent variables natin, log labor and log capital are all in logarithmic form. Therefore, it follows a certain structural form. And then when we generate the regression model, alam natin kung paano i-interpret. Okay, guys? Okay ba?
Yes, sir.
Alright, sige, tuloy natin ha. Okay, so here we are. Okay, here in this code, nag-generate ako ng log output. I called it log output dun sa OLK object. Pati log labor, I called it log lab, log cap. And then it's equivalent to the log of the output labor capital from the OLK dataset. And then, kasi ang mangyayari yan, magiging 6 yung OLK natin, variables natin sa OLK. Masasama si log out, log output, log lab, log cap, masasama. So I'll just create another object called OLK1, okay? And it's equal to OLK. Tapos, ang sinama lang yung 4th to 6th column. Kasi ito yun. Sorry. Ito, ang isasama lang si log out, log lab, log cap. Tatanggalin na natin to. Okay, para mas madali yung pag nag-model tayo. We only need this anyway. We don't need the output, labor, and capital. What we need are their logs. Okay, follow guys? So you should have created this OLK1. Dapat 3 lang laman niya. Okay, nakasunod ba?
Yes, sir.
Okay, lahat meron na. Pakasagot nga please.
Yes, sir.
Yes, sir.
Okay, good. Thank you. Dali ha. Pau, inom lang akong tubig pa, pwede?
Press, sir.
Baka may comment ka na naman dyan eh. Okay, sige. Dali, napaos na ako. Sa totoo lang guys, ang hirap kaya i-discuss nito. Kasi 400 lines, ewan ko kung kanina hindi kami umabot, hindi namin natapos. Pero at least na-cover naman yung pinaka-importanting points. Tapos I just told the class to just go over the others. Kasi kaya nyo naman maintindihan na yan. Kasi next meeting, yung natin guys, yung yung asynchronous, i-open ko pa rin i-record siya. Pero as I said, i-open ko siya.
1 o'clock, sir, right? 1.
Ano bang natin? Oh, aga-agaan ko mga 1. Kasi wala naman din kayong class. Kasi i-split ko into 2. 1 to 3 siguro. At saka 3:15 to 5:15 para 2 lessons ang mako-cover. Tapos siguro sa Thursday, depende kung ano matapos natin. Kasi guys, magpa-panel regression po tayo. Tapos yung time series. Kailangan maka-time series tayo. Pero gagawan ko na rin ng ganito guys para ang disadvantage lang nito, hindi kayo sumusulat ng code. Yun ang mahirap doon. Pero wala na akong choice talaga. So I'd like to apologize guys nga pala for shelving this to your throat, down your throat, 400 plus rows. Pero labor of love yan guys kasi talagang inisa-isa ko yan. No? I had to summarize and really look at what to put here because in the interest of time talaga. Okay, so going back guys, maglo-log-log modeling tayo. Gagamitin natin to, no? Okay, so ito yung equation 1 natin, guys. Equation 1 pala to, yung origin, hindi. Dapat ito yung equation 1 natin. Control C, Control V. Yung original, guys, let's make this as R. Ito yung equation 1, okay? Okay. Equation 1. Tapos yung equation 2, okay, equation 3. Yung final natin, equation 3. Okay, so after having generated the OLK1 model, OLK1 dataset pala, hindi model. Compare muna natin guys, yung pairs. Gumawa tayo ng correlation matrix ni log out, log lab, at saka log cap. Okay? So if I run this, itong line na to, so may plot tayo. And then from here, we can see that, okay, si log output at saka log labor. Gusto natin guys, si independent variable, highly correlated with your 2 predictor variables. Ang ayaw lang natin guys, si log lab at saka si log cap. Kasi, tinan nyo, napaka highly correlated din sila, no? Sabi natin magkakaproblema tayo niyan saan guys? Sa collinearity, no? Sa multicollinearity, we'll have a problem with that. I prefer actually this one from yung GG pairs na to. Okay. I prefer this kasi dito pinapakita na kagad, hindi lang yung plot, hindi lang yung scatter plot, but also the correlation. Okay, so very convenient. So si log output at saka si log labor, 0.971. Very high yung ano. And significant, no? 3 stars dito. Ibig sabihin, yung correlation nila, hindi aksidente. 3 stars there, that's your p-value, eh, no? That's practically 0.000. Kasi 3 stars siya. Ganon din si ano guys, log output at si log capital. Highly significant din yung correlation nila at 0.973. So we're good with log output and log capital. Log capital in terms of log with respect to log labor and log output. As I said a while ago, yung relationship ni log labor at saka log capital might pose some problems for us because the relationship is very high. 0.96, significant pa. No? Okay, so sabi natin ang problem niyan, mag-aagawan sila in trying to explain. Kasi halos pareho sila eh. So why choose 2, di ba? Bakit ka magdadalawang dadalawang variables kung halos pareho lang naman sila? Diba? So that's the problem there. Yung problem ng collinearity natin. Okay, then let's go here guys. Okay, ito na, magre-regression na tayo. Very simple lang naman yung regression natin. Model 1 as a linear model, log out is our dependent variable. Tapos itong dalawa, yung independent natin. Pwede rin natin lagyan na lang dito ng dot, no? Dot. Tatanggalin na natin to. Ibig sabihin nun, lahat ng variables dun sa OLK. Tatlo lang naman yung variables natin doon. Yung isa, yung dependent variable pa. So ibig sabihin yung dalawa natitira, yung dependent. Okay, na-discuss ko yan guys, di ba? Right? Ito, yung dot na to. Hello?
No, sir.
Ha? Na-discuss ba? Mukhang hindi, kasi parang hindi nyo alam eh. Anyway guys, this is equivalent. Kung dot lang ilalagay ko dyan, ibig sabihin nun lahat ng regressors, lahat ng variables dun sa data natin. Of course, hindi kasama si log output kasi dependent variable na siya. Okay, so let me just delete this. Okay. Alright, then kunin natin yung model. Sabay natin to. Okay. Yan. So this is our regression model, guys. Okay, so we have this, our coefficients. We have the residuals, minimum, maximum. So highly significant, no? And then you have your f-stat here. Okay, p-value ng f-stat is 0, which means that overall goodness of fit ng model, okay. That the variables are able to explain the variability of your dependent variable. Okay, so I have here some questions. Question 1, overall goodness of fit using the APA format daw, APA format. Alam niyo ba guys yung APA format? Na-discuss ba sa inyo somewhere yan, sometime in any of your subjects?
Yes, sir. APA.
Yes, so American Psychological Association. So these are standards on how to report statistical tests or how to write your thesis, etc. Sa thesis nyo, guys, APA format ang pinapagawa, no? Pinapagamit. So this is an example of an APA format reporting. The model output showed that log labor and log capital explain a significant portion or amount of the variance in the value of the log output. Tapos binigay ko yung f-stat, 2 degrees of freedom for your regression kasi dalawa yung regressors natin. 48 is a degree of freedom for your residuals, which is n minus k minus 1. N is 51 minus k, which is 2, yung dalawang regressors natin, minus 1, kaya 48. At f-stat, 645.93, and it's definitely higher than f-critical, or p-value is 0.00. Tapos r-squared 0.96, adjusted r-squared 0.96 then. Okay? All right. What does the coefficient of the determination say about the model? As I said, guys, yung 0.96 na yan, 96% na yan, kunyari yung adjusted r-squared, 96%, tells us that 96% of the variability or variance of your dependent variable log output can be explained by both your log labor and log capital. So mataas yan, no? So does this look surprising? Yes. Napakataas yan for an econometric variables. Mataas tong R squared na, no? Ibig sabihin halos wala nang ibang kailangan na variable para i-explain yung output. Very surprising. Okay, number 3, which regression coefficients are statistically significant? Yung tatlo, no? Setting aside the intercept, it's both log labor and log capital. They are statistically significant. What is the regression equation? Okay, so yung equation number 2 natin, number 2, we can use any of this. No? Equation number 3 pala. No? Log Q sub I is equal to A plus, etc. No? So using equation number 3, how does it look? Sana. Ito. Log wage is equal to A plus B2 times log labor plus B3 times log capital plus error term. Okay, any questions, guys, so far?
Answer.
Okay, interpret the coefficients. Ito na. Ano daw interpretation ni log label, log labor, B1, at saka si log cap, yung B2 natin. Okay, sabi natin dito, guys, alam niyo to, note for log, a 1% change in your independent variable will result to a B% change in your dependent variable, ceteris paribus. So how are these changes called? Anong tawag dito, guys? Yung 1% change in ano is equal to B% change in your other variable. They're called ano? Clue, yan, no? I'm sure na-discuss yun sa economic subjects yun. What do you call it, guys?
Elasticity, sir.
Yes, elasticity siya, no? Pag ang tinitingnan natin, guys, yung percentage sa isang variable, and then compared with the percentage of another variable, it's called elasticity. Elasticity change. So, interpretation natin, guys, for every 1% increase in labor, there's a corresponding B1. What's B1? 0.468. But you have to attach percent. B1% increase in capital and output. And for every 1% increase in log capital, there's a corresponding 0.521% increase in log output. Clear, guys? Clear?
Clear, sir.
Okay, so APA format style, no? Ito. Okay, ito yung mas full na version na APA. So, kunyari, nag-regression na kayo sa paper nyo, i-discuss nyo yung regression output. So, this is the standard way to present the output. A multiple linear regression was calculated to predict log output based on log labor and log capital. A significant regression equation was found with F stat degree of freedom 248 equal to 645. P is 0.00, again yung R squared at adjusted R squared. The model's predicted log output is equal to, yan, yung equation natin, where log labor and log capital are measured in $1,000, okay? And then log output increased 0.468% for each 1% of log labor and 0.521% for each 1% of log capital. Both log labor and log capital were significant predictors of log output. Okay, sample lang yan, guys, kung paano pinapakita yung regression results. Alright. Then, ano advantage, guys, kapag naglo-log tayo? Advantage is that yung elasticities, guys, they are pure numbers. Ibig sabihin, kaya nga pag ini-interpret yung kanina, tinatanggal natin yung units. Walang units yun. Okay, kasi pag elasticities, guys, nada-drop off. Pag you can prove that, guys, makikita nyo magka-cancel out yung mga units. So you interpret that as percentage change and not units change. Okay, then number 7. Okay, ito. Tama ba to, guys? Let me copy this, Control C. Tapos balik ako sa Word. Saan yung Word natin? Okay. So ito yung equation natin, di ba? Alright. Ang sabi, yung equation ba raw natin is tayo. Okay. Sabi daw, log Q is equal to what, guys? Ano yung constant natin? 3.8867 ba?
887.
Times
76, sir.
76. Okay na. 76. Sige. Times labor times ano to? 0 point ano?
46833.
4683. Capital times what?
0.52128.
Okay. Yan.
28.
Tama ba yan, guys? Kasi lumabas dun sa regression output natin, yung A natin, ito. Diba? So is this correct, guys? Kasi you're using now, what are you now using? Ay, hindi. Sorry wala dapat log to Okay. You're converting, guys, to ano? We are converting to equation 1 natin. So Q1 is equal to si B1 natin 3.8876 times labor raised to the B2. Ano ba yung si B2? 0.4683 times capital, okay, capital to 0.522128. Okay, is that correct, guys? That was the question. Answer? Correct ba siya? Answer is? No, mali yun. Bakit? Tingnan ito, guys, yung equation natin. Look at this. Look at this. Okay? Q1 is equal to B1. Yan. Ang question, ano tong B1 na to? Si B1 ba ito? What is this, guys? Yung 3.88. Ito yung nasa regression model natin. Ano ba yung regression model natin? Di ba ito? Equation 3. Di ba? Ito si A. So is A equal to B? Is A equal to B1? No. Hindi sila equal. Ano relationship nila? What's the relationship, guys? We know that si A, pinalit natin dyan kay, sino? Log B1. Tingnan yung equation, guys. Yung equation 2. Yan. Di ba ito yun? Log B1. Tapos sabi natin, since constant naman to, pinalitan natin ng A. Alright, guys? Okay? So how do you now get B? Ang kailangan natin sa B, si B para yung equation natin, format equation 1. Yun ang gusto natin. So what we need is B1. Do you get me, guys?
Yes, sir.
Okay. Yung equation 1 kasi natin ito, di ba? Hindi naman A yung andi dito eh. It's B1, di ba? Pero yung generate natin ng intercept, it's A. Kasi nga, pinalitan natin yung log B1 ng A dito. Okay, so how do you now compute for B1? We need B1. Well, mathematically, guys, ginaganto yan. E to the A, kinukuha yung exponential. E to the log B1. Alam nyo si E is a transcendental number, 2.7, 1.4, etc. Parang pi yan na walang katapusan na number. Alright, so E and log are inverse functions, so tanggal to. Okay, therefore, so bababa na si B1, tanggal na itong dalawa, B1 na is equal to E to the A, which is equal to E to to the 3.8876. Yan. Yan ang value ni B1, guys. Okay? So, solve natin sa R. Let's go back to R and solve for it. Okay. So, mali ito, no? Diba? This is wrong. So, ano yung tama dapat? Let's solve for B. Ito ko lang gawin. Solve for B. So, B daw is E to the A. So, parang sa Excel din, ang E, guys, is EXP. EXP ni, exponential ni A. And that's so that should be 48.7936. Okay, so the equation should be this one. Dapat ito yung equation natin. Sana? Okay. Here. Q sub I is equal to 48.7936 times L sub I to D 0.46833 times K sub I to D 0.52128. Okay, guys, clear?
Sir.
No questions?
None.
Okay, sige. Next. So, sabi natin, na-generate natin yung model natin, whether you express it in terms of yung Q sub I, or kung ako susulat yan, i-express ko in terms of log Q. No? Kasi mas madaling i-interpret. Dito kasi, mahirap to kasi guys, naka-exponent yung ano natin. Kaya nga tayo nag-log. No? So, log Q is equal to 3.8876 plus 0.46833 times L sub I plus 0.52128 times K sub I. Okay, so that's our model. No? Okay, so una guys, we don't stop there. We don't say that, okay na tapos na tayo kasi okay na yung model natin. We have to do diagnostic tests kasi may mga assumptions ang classical linear regression model. So magkakaproblema tayo kung hindi natin i-test yun. No? Kasi baka may mga violations. Okay, ano yung mga assumptions natin, guys? Give me one. Guys. Hello. Ano yung mga assumptions natin ng regression, guys, ng classical linear regression model in order for the model to be accepted? Hello, everyone? Ano? Come on, guys. Oras natin, hinahabol natin yung ano. Give me one example, guys. Give me one assumption. Hindi ako magtutuloy, guys, kung hindi kayo sumagot. Ano yung mga assumptions natin ng classical linear regression model?
Sir, the regression model is linear.
Okay, linear. Ano yung linear? Dalawa yung linearity dyan, guys. Ha? Dapat yung parameters, linear siya. Tapos linear yung relationship ng y at saka ng independent variables natin. Dapat may linear relationship sila. Bakit ganon? Kasi paano kung ang relationship nila quadratic? Eh di, pangit yung model natin kung ang ginamit natin linear regression. So dapat linear yung relationship nila. Hindi dapat parang polynomial. Yung plinat natin kanina yung scatter plot ni log output at saka ni log labor, di ba? Nakita nyo na parang line, highly correlated. Okay, aside from linearity, guys, ano pa? Linearity in parameters, linearity in the relationship between x and y, ano pa? Dami tayong diniscuss ha. Ano pa guys? Ano pa? Come on, we're wasting time.
The error term has a population mean of 0.
Ah? Oo, lagi naman ganun eh.
Well, assumptions pa po.
Oo, hindi naman assumption na sa bagay pwede rin, sige, isama na rin natin yun, pero hindi siya kasi pag minin talaga yung zero naman talaga yun eh. O, ano pa? Sige.
Yung normality
Normality ng ano?
ng mga residuals kailangan
Okay.
normal.
Okay, pero sa dulo yan pa, huling sa pinaka hindi importante quote unquote, no? Ano pa guys? Multicollinearity guys. Dapat yung mga independent variables natin hindi sila correlated, di ba? What else? Variance ng error terms. The error terms should exhibit constant variance. Pag prinat mo yung residuals guys, yung error terms, dapat walang pattern. Dapat random lang siya, parang night sky lang. Parang pag tumingin ka sa gabi sa sky guys, ano makikita mo? Wala namang shape yung mga random siya, di ba? Yung mga shape ng arrangement ng stars. They're all random. Okay? Parang ganun dapat yung regression natin. Okay? Ano pa? Autocorrelation. Dapat yung mga error terms natin, hindi sila correlated. But sabi natin dati, this is more a function of time series. Nagkaka-order lang naman yung correlation ng mga residuals kung talagang may ordering dapat sila. Pero kung cross-sectional, kasi pwede mo ipagpalit-palit yung order niyan eh. It doesn't matter. So wala tayong issue ng autocorrelation sa cross-sectional data. What else guys? Tapos andyan pa yung mga outliers natin, leverage points and influential points among others. So let's proceed guys. So ito, ang gagawin natin dito muna, gagawa muna tayo ng, ang tawag dito, global validation of linear model assumptions. Parang overall to. So titingnan dito yung skewness, kurtosis, linearity assumptions, heteroscedasticity. So may mga linagay na ako notes dito guys for your perusal. So based on kay Pena at saka sa Slate, sinabi nila na yung assumptions dapat sa linear, sa regression should be linear, dapat linear regression, yung relationship ni Y at saka ni X, normality, sinama nila, heteroscedasticity, and linearity. Ito yung apat na sinasabi nila, no? Okay, ito yung reference yan. Okay, so dito sa GV, Global Validation of Linear Model, sa code na to, i-generate tong output na to. Okay? And then, so may mga explanation dito ng konti. Okay? Then, of course, you can study further and research more on anong ginagawa ng GV model na to. Okay, let's run this. Okay. So si GV-LMA guys, iraran ulit niya yung regression. Ipapakita niya ulit yung output. Tapos nasa ilalim yung assessment of the linear regression model. Okay? Ano sinasabi niya dito, guys? In terms of global stat, hindi yung model nito hindi na meet yung assumptions ng classical linear regression model, pati sa skewness at saka sa kurtosis, which means na medyo not normally distributed yung natin. Pero yung link function at saka yung heteroscedasticity, ang according to GV-LMA, na-meet siya. Okay, so dito may linagay lang ko notes dito about what the global stat means, about the skewness. Alam natin na si skewness, distribution yan. Okay, kung normally distributed yung error terms natin. Tapos yung link function, kung misspecified yung model natin at saka, well, yun lang, more on the specification. Ang ibig sabihin guys ng specification, kunyari, yung kanina, minsan kung hindi nyo linolog, yung isang dapat na variable na dapat linolog, ang tawag dun guys, misspecification. Kasi mali yung model na ginamit nyo. Dapat nakalog yung isang variable. Nari yung log, yung output kanina. Let's assume that should be logged. Tapos nag-model ka na hindi nakalog. Ang tawag dun guys, misspecified yung model natin. Okay? And then alam natin yung heteroscedasticity. So dito may dalawang okay tayo, tapos may tatlong problem tayo, no? Sa normality of residuals, ito sa mga outliers din tong sa kurtosis, and then sa global stat yung overall linearity. So, but we don't stop there. Okay, we will have to look at this in greater detail. No? So, parang overall test lang yan si GV LMA. Okay. So, let's proceed, guys. Any questions?
None.
Okay. So, pag plinat nyo to, guys, ito yung partition natin into 2 rows and 2 columns. Okay, nga pala, yung unang-una natin is we're looking at outliers, leverage, and influential data points. Okay, may kaibahan yan, guys, si outliers, si leverage, at saka si influential data points. Pwede yung isang data point na outlier, pero hindi siya influential point, then okay lang yun. Ang talagang binabantayan dyan, guys, yung influential data point. Pwede rin siyang may mataas na leverage, pero kung hindi naman siya influential, okay lang din yun. What we're after is yung influential na data points. Okay? So here we're going to plot the residuals first, and then we'll be able to detect visually lang. Visually lang natin makikita to kasi minsan ang hirap i-ano visually. But we will have statistical tests for this. Okay, so tingnan natin, guys, pakiran tong dalawang code na to. So magkakaroon tayo ng dalawang 2 lines, 2 rows, 2 columns ng residuals. The first is residuals versus fitted. So nasa x-axis natin yung predicted values, nasa y-axis yung residuals. Ano dapat to? Dapat, guys, yung mga puti-puti na ay mga dots na yan, those are the residuals. Dapat yung mga residuals dapat nagko-congregate sila dun sa line na to. Dito sa y is equal to 0. Pag medyo lumilihis na sila, kunyari over time, kunyari, over the predicted value, lumalaki sila ng lumalaki, may problema tayo. Yung fanning out, naalala niyo, guys, pag habang nag-i-increase yung natin, yung predicted value, lumalaki din yung yung residuals natin, then we have a problem. Tapos dapat, guys, yung red line na yan, dapat as much as possible, straight line yan. Pag medyo tumataas siya o bumababa siya, ayan, may problem tayo yan. Okay, so I have written here some notes, guys, for your reference. Okay, ito sinasabi dito, the first plot, residuals versus treated values. Ginagamit siya for checking the assumption of linearity and homoscedasticity. Okay, paano natin malalaman? Your scatter plot should look like the night sky. Ito yung sinasabi ko sa inyo, guys. No? Kailangan yung scatter plot natin parang paggabi, pag tumingin kayo sa himpapawid, guys, sa alapaap, makikita nyo na, oops, yung mga stars, wala siyang pattern. Random siya. That's what we want for our residuals. No distinctive patterns. The red line daw, sabi, should be straight and horizontal, not curved. If the linearity assumption is satisfied. Okay. Then itong QQ plot natin, guys. Dapat, guys, yung mga residuals natin, guys, dapat nasa line na to. By the way, ito, makikita dito, guys, may mga candidates tayo for outliers. Ano? Itong 32, 8, at saka 27 na to. Parang medyo nawala sila. No? By the way, guys, ano yung outlier? Ano yung outlier? Ano difference ng outlier at saka ng leverage? Kasi tatlo yan, di ba? Outlier, tsaka leverage. Okay. Yung outlier, guys, pag medyo, kunyari mga values natin ganito. Then data points natin. Tapos medyo, yung isa andi dito. Yan. Ano ibig sabihin? Hindi naman siya nagkakalayo kay X, di ba? Ito yung mga X natin, eh, ano? Yan siya. Malapit siya sa mga regular na X values. Pero sa Y values, guys, ang layo niya, no? Ito yung pinakamaliit, eh. Ito. Parang masyado siyang Pag ang difference, guys, pag unusual siya in terms of the Y-axis, ang tawag dyan outlier. On the other hand, if the data behaves in a way that seems to be, narigito yung data natin. Tapos, andito siya. Yan. Okay, tingnan nyo guys. In terms of Y, okay lang naman siya kasi may mga Y dito, di ba? Yan, no? Okay lang siya in terms of Y. We have a cloud of data here. Pag titingnan mo sa Y-axis, may mga kapareho siya. But in terms of X, guys, okay, malayo siya. No? Yan. Bukod tangi siya kay guys na ano, yung ibang X ang range lang hanggang dito eh. Diba? Siya andi dito. So pag ganyan guys, pag medyo unusual siya in terms of the predictor, the x-axis, this is called your leverage point. Unusual in Y, that's your outlier. Unusual in terms of X, that's your leverage point. Now, hindi lahat ng outlier or leverage ay influential. Ang binabantayan dyan guys, okay lang na mag-outlier siya, okay lang na mataas yung leverage niya, for as long as hindi siya influential. Okay, but definitely guys, yung influential data points nanggagaling either sa pagiging outlier niya o pagiging mataas yung leverage na. Okay, hindi ka pwede maging influential tapos hindi ka naman outlier or yung leverage point mo. Okay? Pero the reverse is not true. Pwede kang maging outlier na hindi ka influential. Pwede kang mataas yung leverage na hindi ka influential. Okay? Tapos ang pinaka-importante sa atin yung influential. Not the outlier at saka not the leverage points. Clear guys? Clear ba?
Yes, sir.
Nakita niyo ba yung word na dinawin ko?
Word ba, sir?
Ay, naku, hindi naman kayo nagsasalita. Oh. Ang dami ko na sinulat dun sa word. Ayan. Kaya palang, ba't ang tahimik nyo? Ulitin ko lang yung sinabi ko kanina, guys. Ha? Just to drive home the point. Ito, kanina nag-drawing ako dito. Ulitin ko na nga. Okay, ito. Kunyari, ito yung ano natin. Ito yung scatter plot natin. Okay. Then meron tayong isang point dito. Yan. Can you see, guys?
Sir.
Alright. In terms of X, guys, kasi andito yung concentration ng X values natin within these values. Okay lang siya, di ba? Kasi pasok siya dun, di ba? Hindi naman siya nalalayo sa X values eh. Pero in terms of Y, ito kasi yung yung natin sa Y, eh. Itong range na ito. Pero siya andi dito. Okay. So kapag medyo unusual siya in terms of Y, in terms of the value ng ano natin ng dependent variable, this is what we call an outlier. Outlier yan. On the other hand, guys, pag medyo, ito naman, tingnan nyo to. Oh, tingnan nyo to, guys. Ito yung scatter plot natin. Tapos itong isang point na to, in terms of Y, okay lang naman siya. No? Kasi, ando doon siya sa, ano, sa kasama ng iba. Pero in terms of X, ito lang yung medyo malayo siya doon sa iba. No? Ang tawag dyan, leverage. Okay? Clear, guys?
Yes, sir.
Okay, so ang importante sa atin, well, importante din yung ano, importante yung outlier and leverage in the sense that doon nang gagaling yung mga possible na influential points. Hindi ka naman pwede maging influential kung hindi ka either outlier or may leverage ka. No? All right. So, dito guys, sa pangatlo, dito na tayo, no? Ano yung scale and location? Okay, so, nagbigay ako ng explanation dito guys. Yung third plot, scale and location plot. Dito, ang pinaplot, yung square root ng standardized residuals at saka ng predicted value. Okay? Yung kanina sa number 1, residuals lang versus the fitted value. Ito naman, squares ng, okay, square root ng standardized residuals. So hindi residuals ha. Ito residuals, okay, ito standardized residuals. Ibig sabihin, kinonvert na yung ano yung mga residuals into a one that follows a normal distribution. Okay, standardized siya. Sa Excel is equal to standardized yan. Alright, so saan na tayo dito? Importante ito for checking the assumption of homoscedasticity. In this particular plot, we are checking to see if there is a pattern in the residuals. Parang sa number 1 lang din to. Okay, may pattern ba? Ang nakakatakot lang dito guys, itong line na to. This line, okay, dapat straight kasi yan, pero medyo pababa dito. So parang may pattern siya dito, we're not sure. Okay, but we can check this via, again guys, ano pa lang to yung visual pa lang. So again, dito yung mga possible na outliers. Outliers 32, 8, 27. Napaka-consistent nila. Yung third guys, pinapakita dito yung Cook's distance. Ang importante dito sa Cook's distance, dito sinasabi kung ano siya, kung influential. Okay, kung influential siya, kunyari itong 32, mukhang influential to, no? But we have to test this also. Okay, so may bagong pumasok si 19, dati wala yan dito eh. Okay, then si 27, doon pa rin. Si 8 na wala, no? Parang hindi na siya considered as possible na influential. Alright. Okay, so andito yung explanation guys. I hope you read through this. You can also generate the same plot guys na mas malaki by doing this. I-identify natin plot 1 kanina. Okay, pareho lang, di ba guys? Plus 2. Ayan, yung normal QQ plot. 3. Side location. Yung number 4. Yung leverage. Okay? Yung Cook's distance natin. Ano advantage ito guys? Mas malaki, mas magandang i-copy for your any output for example. And then meron pa tayong isa yung 4. So si 4, ito yung plot ni Cook's distance. Okay? Interpret na natin to mamaya. Nangunguna talaga sa Cook's distance si 32, tapos 18, tapos si 27. Tapos nawala na si number 8, no? Wala na siya dito sa list. So possibly na naging, ano siya, it tells us na pwede kang maging outlier pero hindi ka influencer. Bakit importante na guys malaman natin kung sino yung influential points? Kasi nakakaano yung mga points na yan. Nakakasira ng model yan. Masisira yung yung prediction nyo kung ano doon yan, tapos ano pala yan, kung mali. Kasi bakit naging ganyan? Possibly guys, nagkamali ng input, nagkamali ng coding. Pwede yon. Tapos how do we address that? There are several ways to address that. The last guys is tatanggalin yung data. Yun ang pinakahuling alternative. No? As much as possible, dapat hindi tatanggalin yan. Ano yung mga pwede? Okay. So, kunyari, hindi natin pwede mabalikan yung respondent yung interview natin. Pwedeng may mga different ways. One way is to replace that, yung influential point natin, ng average niya. So, i-average natin yung point na yon. Okay? So, that's just some examples. Alright. Ito, pareho lang ng mga plot sa taas. Mas gusto ko nga lang yung nito, yung plot view. So this is autoplot. This is from GG45. Okay, I prefer this kaysa dun sa isa kanina na yung yung pagkalinis ng ng plot, no? All right. So yung sa mga residuals guys, ito yung nakikita natin, residuals versus fitted. Yung normal QQs, K-location, residuals versus leverage. So it tells us something about the validity of our regression model. Okay, any questions so far, guys?
None, sir.
All right. Sige, punta tayo next, guys. Okay, so this will generate a table where andun si residual, si Cook's distance, okay, and iba-iba pa. So let's just run that. This is coming from the Brooms package. Tingnan nyo. It's a table, guys, no? Kasi head lang kinuha ko nito. So we constructed an object called head that diagnostics.metrics. Ang code natin yung augment. Yung augment coming from the Brooms package. Naalala mo yung dati ginamit natin to sa regression. Pinaganda niya yung output. Okay? Alright, tapos andito si residual, andito si hat, si sigma. Ito yung Cook's distance natin. Kaso nga lang, yung Cook's distance dito, hindi naka-arrange. So siguro, mas maganda kung we use this code naman. Okay, we're creating an object called Cook's distance. I-round natin siya. Okay, round into 3 decimal places lang. Ito, round plus 3. Tapos sorted siya. So, sort natin si, the code is Cook's.distance ni model 1. Tapos decreasing siya. Decreasing is equal to true para malaman natin kung sino yung pinakamataas dun sa Cook's distance. Let's run this. Okay, and then you see guys, yung number 1, talagang si 32, ano? 32, tapos si 19, si 27, tapos si 8. Okay, the rest are wala, no? Not candidates for influential points. Alright, so dito nakita natin nga si 32 nga yung pinaka may influential, quote-unquote. Alright, tapos ito naman guys, mga plots dito, naalala nyo si OLSRR, yung pinagkuhaan natin ng ng stepwise regression. Pwede rin dito 'yon, no? Kaso nga lang dito, OLS plot, Cook's distance yung pinapaan natin. Cook's distance bar, Cook's distance chart. Let's do this. Okay. So again, dito naman yung mga highest pointers natin, no? Okay. Ang threshold daw 0.078. So andi dito yun, ayan, yung red line na yan, guys, oh. 0.078. So lumampas tong apat na to ng threshold na yan, which indicates that kasi ang normal guys, yung nasa blue, yung hindi lumalampas ng threshold. Itong apat na to, lumampas sila lahat ng threshold ng 0.078, indicating that they are possibly influential data points. And then this is just the same, kaso nga lang hindi na siya lines lang siya, no? Personally, I prefer this. Okay, guys? So far, tinitingnan natin si outliers, si influential, si leverage data points. Okay? Let me close this. All right. So I gave here some notes, guys, about Cook's distance. Inintroduce siya ni Dennis Cook, American statistician. Okay, so sabi niya, it is used to identify influential data points and it depends on both the residuals and the leverage. Okay, yung outlier na residual, it takes into account both the x values and the y values of the observation. Bakit yung x values, guys? Sa x values kasi dyan natin makikita si leverage. Sa y values naman natin dyan makikita yung outliers natin. Okay, this just tells us how Cook's distance is computed. No? So i-plot natin to. Alright. Now, hindi lang si Cook's distance ang pwedeng ginagamit to identify yung mga influential data points. Pwede rin si DF beta at DF fits. These are also measures of influential data points. Ito, this is difference in beta, yung parameters natin. This is difference in fitted values. Ang ginagawa dyan in principle, guys, so ando doon lahat ng data points natin, magre-regress tayo. Di ba magkakaroon tayo ng predicted value na y? Tapos ang gagawin, kukunin yung pinakamataas na Cook's distance, tatanggalin siya, tapos magre-regress ulit, tapos i-compare yung predicted value ng nauna kaysa sa pangalawa. Kukunin yung difference nun. Okay? And then, pag kinuha na yung difference, isa-sum up yun, tapos may manipulation na gagawin, then makukompute na yung either Cook's distance, DF beta, and DF fit. Okay, so naran na ba natin to? Hindi pa. DF betas, naran natin. Okay, so sa DF betas, guys, pinag-uusapan kasi natin dito yung pag-beta, di ba yung coefficient ng mga independent variables natin. So, meron yung independent variable na DF beta ni log lab at saka DF beta ni log cap. So dito, ang threshold ng DF beta is 0.28. So makikita natin kung sino yung may mga DF betas na more than 0.28. Siya yung mga candidates for influential data points. Again, ang objective natin guys for determining Cook's distance, DF fit, DF beta, iisa lang para ma-determine kung sino yung mga possible na mga influential data points. Okay, clear guys? Clear?
Yes, sir.
Okay. Ito naman si DF fit din, parang kapamilya to ni DF beta. Ang mini-measure dito yung fitted value, yung difference ng fitted value. Yung kanina naman, beta, ang kinukuha dyan, yung difference ng mga betas, ng mga coefficients. Yung differences based on the model. Alright, so, sige, let's continue. Hala, konting panahon na lang. Okay, so may ano lang ako dito guys, may mga comments ako about you may peruse this for your reference. Okay. Alright. Now, na-mention ko kanina outlier. Sabi natin yung outlier, yung medyo unusual values in terms of the y-axis, no? Okay. So, ano to, yung more on kay dependent variable kasi si dependent variable nasa y-axis, no? Okay, so pwede natin i-test kung merong outliers natin sa data natin, no? So we can do what we call the Bonferroni test. Ito. Ang null hypothesis niyan is the data dapat hindi this test. The null for this test is that there are no outliers. Okay, yun ang niyan, no? There are no outliers. So i-generate natin, ito yung test natin diyan. Outlier test model 1. Enter. Okay, so ito yung si Bonferroni. So, anong conclusion natin? P-value is practically 0. So, sabi natin, when the p-value is low, the null must go, di ba? So, i-reject natin si null hypothesis. Anong null hypothesis natin? That there are no outliers. Okay? So, rejected to. There is the presence of outliers. Yun ang sinasabi ni Bonferroni test to detect outliers in the data. But then again, guys, sabi natin, kahit na may outliers, hindi naman nangangahulugan na yung outlier na yan is an influential data point. So we have to go deeper and investigate kung yung mga outliers na yan na pinesent sa atin sa residual plots kanina, if they are really influential data points. Okay? Alright. So, may dalawa pa pala tayo dito, no? Ito pareho lang to guys, no? It's just the same plot as yung kanina, yung QQ plot. So, kita natin na ang mga possible candidates, si 32, si 8, no? These are possible candidates for being influential. Okay, and then this one, ito, saan ito? Where is that one? Ito guys, leverage. Okay, so leverage naman, okay, leverage plots naman, okay. Sabi natin, this has something to do with the unusualness in terms of your x-axis. Ang x-axis natin, yung mga regressors natin, si log lab at saka si log cap. Okay, and here we can identify for log labor, ayan, andyan na naman si 32, at saka si 8, at saka si 19, pero dito may 51. No? Kay ano naman, kay log capital, yan, highest pointer talaga si 32, si 8, si 19, may 51 din dito. Okay guys, clear? Plot na ng leverage plots at saka ng yung sa Cook's distance natin, no? Okay. Outlier pala, sorry. Outlier ang tinitingnan natin dito. Alright, so based on the test above, we see that 32 as an outlier. But remember, an outlier is not necessarily an influential data point. Okay. Sabi ko guys, si Cook's distance, may way yan kung paano kino-compute. So one way to compute the Cook's distance, parang benchmark siya, na kapag lumampas ka dun sa count na yun, influential ka. So it's simply 4 over, this is the number of observations minus length ng model 1 ng coefficients, kung ilang kung ilang parameters. No? Then 3 kasi kasama yung intercept, then minus 2. Okay, so let's run this. Ito muna. So now. Then this one, control enter. Okay, ang cutoff 0.086, no? Tapos i-plot natin. So ang ibig sabihin niyan guys, ang cutoff na yan, based on that formula, kapag lumampas yung Cook's distance mo ng isang data ng 0.869, then ibig sabihin possible ka na influential. Yan. 0.08, andito yung 0.08. Although napakita na natin to kanina, no? We already showed this a while ago. Okay, so hindi ko pala napasok dito yung yung statistical test ng influential. Okay, sige, idadagdag ko na lang yung guys, no? Kasi may ipapadala pa naman ako sa inyo. Okay, next is heteroskedasticity. Diba? Sabi natin na yung data points natin dapat homoskedastic siya. Anong ibig sabihin ng homoskedastic? Guys, ano ibig sabihin ng homoskedastic, guys? Constant variance, no? Homoskedastic, guys. Constant variance. Yung error terms natin dapat equally scattered, no? Hindi pa pwede yung may tawag nito, may pattern dun sa error terms natin. Okay, so there are 2 ways to test this. One is, maraming way pala, no? Dalawa lang to sa ginamit natin dito. One is the NCV test. This means non-constant variance test. Okay? And the other one is the Bruce-Pagan test. Okay. Yung NCV test, mas luma na to. And si Bruce-Pagan test, yung particular parameters niya na gagamitin natin, mas robust siya. Okay. Kaya minsan nagkakaroon ng discrepancy katulad nito. So simple lang test niya, NCV test module 1. Okay, sige, run ko. Alright. Non-constant variance test. Okay, ang ginamit fitted values. Tapos dito, chi-square is 10.46, degree of freedom 1, P is 0.001. Ano ibig sabihin nun, guys? Reject or not reject? Hello? Given that P value, guys, ano magiging conclusion natin? Reject ba natin or not reject the null hypothesis? Answer?
Reject.
Guys, reject kasi less than 0.05, no? Reject natin yung null hypothesis. Ano ba yung null hypothesis natin? Na homoskedastic yung error terms. Okay? Yan nakalagay yun. There is a constant variance or homoskedastic. Re-reject natin re-reject natin yung hypothesis na constant yung variance yan. Therefore, guys, we were not able to prove na homoskedastic yung error terms natin. And there's this other one, guys, si Bruce-Pagan. Okay? BP test. Tingnan naman natin to. Ganun din yung ano niya. Residuals are homoskedastic. If you run this, okay, ang lalabas, 0.08. So, dito, we fail to reject the null hypothesis at 5%. We fail to reject the null hypothesis that the residuals are constant. So based on the Bruce-Pagan test, constant yung variance, homoskedastic siya. Anong susundin, guys? Okay, ang susundin natin, ang reason dito, guys, iba kasi yung pag-compute nila. No? So ang mas powerful, guys, yung Bruce-Pagan, particularly this one, yung pangalawa na to. No? Mas robust siya. Okay? Yan, no? Ano to? TA modification of the Dayata to. Mali yung grammar ko. Is suggested which correctly studentizes a test statistic and leads to. Okay. Ito. Sinabi ko dito. The studentized Bruce Pagan test. Kasi tingnan nyo guys, ini-studentize yung ano yung residuals natin. Is more robust. Mas okay siya than the original one NCV test. Although pwede mo rin makuha yung output na yan sa NCV test, kailangan may mga parameters ka lang na ilalagay din. Alright, so if I run this, okay, 0.1559, therefore we fail to reject the null hypothesis of equal variance. There's strong reason to believe that our error terms are homoscedastic. Okay, ang susundin natin yung mas robust na parameter, si BP test. But it pays guys to test both NCV at saka Minsan naman pareho silang output. But if they fail, if they contradict, mas gagamitin natin si BP test. Okay, so what do you do guys? Paano kung may heteroscedasticity? Okay, buti lang ngayon guys, yung mga softwares ngayon, pwede nang i-correct yan kasi nagkakaproblema tayo dyan sa standard errors. So kapag heteroscedastic guys, malalaking standard errors natin, di ba? Kasi non-constant variance, either nag-i-increase over time yung error terms natin, yung residual terms natin. Okay, so anong pwedeng gawin dyan? Well, pwede natin i-rebuild yung model with, kung meron pa tayong possible na new predictors, then either magpalit or magdagdag kung kailangan. Okay, there are also transformations like box-cox transformation. So hindi na natin sakop tong box-cox na to. But this is interesting, especially kung talagang heteroscedastic yung error terms. Isa sa unang pinupuntahan yung mga power function like box-cox. Okay, so meron nito sa R guys. Ngayon na medyo well-versed na kayo sa R, I'm sure you can go to the internet and look for box-cox transformations. Just in case you have distribution of your error terms which are really heteroscedastic. Okay. Okay, ito guys, functional form. Meron pa tayong some more minutes. Ano naman yung functional form? Kunyari, yung data natin, ang relationship ni X at saka ni Y, medyo quadratic. No? So, hindi linear. And yet, ginamit mo guys yung linear model. So, magkakaroon tayo ng isang problem natin dyan is what we call the functional form. Yung structural form ng model natin, mali. Okay? So, that's what we call the testing for the functional form. Okay, so dapat naka-squared yung X mo, dapat i-square yan. Okay? Kasi mamali tayo sa functional form. Okay, so ito guys, how do you test that? Meron ng test diyan, yung tinatawag natin na Ramsey reset test. Ito yung regression specification error test. Okay, anong ginagawa nito? Ang ginagawa ng Ramsey reset test, pag nag-model ka na, nag-LM modeling ka na, maghahanap pa siya ng another model. Ang gagawin niya, kunyari, yung X natin, pwede niyang i-square, pwede niyang i-cube, para makita niya, baka naman wrongly specified yung model mo. Baka may X squared ka dapat o may X cube ka. Kuha niyo guys. Hello, guys?
Yes, sir.
Yeah, okay. Ganun lang yung concept nun. Nag-modeling tayo, wala naman tayong X squared dun o X cube sa natin, sa independent variable. Ang gagawin ni Ramsey, i-square ko kaya itong X na to, i-cube ko kaya yan, pati ibang independent variables. Tingnan natin, baka mas maganda pa yung lalabas. Diba? Na output. Ang ibig sabihin nun, guys, pag ganun lumabas, pag mas maganda, may wrongly specified yung model natin. May misspecification tayo. Bakit may misspecification? Kasi lumabas na mas maganda kung kasama yung variable na X squared. Kasama yung variable na X cube. Mas maganda pala kung ganun, bakit hindi mo sinama? So, misspecified yung model natin. And that can be tested using Ramsey reset. So, ito yun guys, Ito yun. After you run a simple linear regression, kunyari ito, This test runs another regression model. Okay, so ang gagawin niya, since si X guys, yung regressor natin, i-square niya to. Tapos, i-cube pa niya. Tapos pwede yung isasama pa niya yung predicted value. So ganyan ang ginagawa ng Ramsey reset, no? Isasama niya si X squared, isasama niya si X cubed, isasama din niya si predicted value, isasama pa niya yon sa model. So para magkaka-y hat ka dun sa independent variable. Naka-y squared siya, naka-y cubed siya. So ganun guys yung Ramsey reset. Okay, so gawin natin dito. Okay, so ang null hypothesis natin, the restricted model is better. Ibig sabihin, okay na yung okay na yung current model natin na walang additional na regressor. Okay, so ito yung code natin, reset test. So sino i-reset natin? Si model 1. Okay, tapos ano yung code natin? Ano yung parameters natin? Yung power up to the third, second, and third. Tapos type, ano yung type natin? Yung regressor. Okay, and data, OLK1. Okay, sige, i-run natin guys. Tingnan natin kung may misspecification tayo or may mali tayong functional form. Run this. Okay, ano daw? Reset test. Ramsey reset, 0.68, degree of freedom 4. Okay, bakit naging 2 degree of freedom guys? Bakit 2? Kasi, guys, degree of freedom 1, 4. Bakit, guys? Nag-insert siya ng 2 bagong predictor. Okay? Na naka-squared at saka naka-cube. Okay? I have to check, guys, kung okay. So, si log cap squared, log cap cube, pati si log labor cap squared, log labor cube. Yun ang pinang-regress, no? Anong lumalabas? P-value is 0.6092. Therefore, ano?
Accept null.
Oh, hindi tayo nag-accept null, ah. We failed to reject, no?
Failed to reject, sorry sir.
Yeah, thank you. We failed to reject the null hypothesis na mas maganda yung yung restricted. Yung restricted yung hindi natin dinagdagan yung original model natin. Okay? So ibig sabihin, okay tayo, wala tayong misspecification. Okay? Hindi lumabas dito na mas maganda kung in-square mo pa yung log cap at saka in-square mo yung log labor. Hindi raw sabi niya. No. Mas maganda na yung original model. Okay? All right. Then ito, alam natin tong collinearity, no? Time na pala guys. Pwedeng extend ng 3 minutes guys. Tapusin ko lang tong collinearity, ha? Okay lang ba?
Go lang, sir.
Sige, thank you. Okay, ito na lang guys. Collinearity. Okay? So alam na natin to guys, no? Importante lang i-check natin kasi pag may multi-collinearity tayo, extreme yung situation na yan. Kasi kung meron yan guys, ano daw mangyayari? What will happen? Nagiging unstable yung model natin. So isang gamit guys ang regression is for prediction. Kung hindi na stable yung model natin, palpak na yung magiging natin guys, magiging forecasts or mga predictions. And alam natin VIF yung isang pag-measure niyan, kaya using the car, dapat hindi ko na inanto to kasi na-load na naman natin to. Okay? Okay guys, yun nyo when faced with multi-collinearity, the concerned variables should be removed since the presence of multi-collinearity implies that information that this variable provides about the response variable is redundant, no? Nag-aaway sila guys, no? Tapos sabi natin guys, kapag may multi-collinearity, hindi pa pwedeng sabay-sabay lahat tatanggalin, di ba? Doon sa backward regression natin, isa-isa lang. And may may candidate kung sino yung tatanggalin. And you can also use the OLSRR. Okay, so dito tinest natin, VIF. Look, guys, ito na expect ko kanina kasi highly correlated to si log labor at saka si log cap, no? Okay, so anong tatanggalin natin dyan, guys? tingnan natin yung sino ba mas mataas na p-value sa kanila. So that could be the basis. No? Tanggalin niyo yung pinakaasan yung output natin. Andiyan pa sa inyo yung output niyo, guys? I think yung pinakamataas na p-value si log cap, kaya yun yung tinanggal ko. No? Okay, so nung tinanggal ko siya, guys, ano nangyari? Tinanggal ko. Okay, ito masusundan nyo na, guys. Ha? Kasi aside from i-compare ko ngayon si Model 1 at saka si Model 2. Si Model 1, tinanggal natin si log cap. So sundan nyo lang yan, guys. Tapos meron din tayo ANOVA, we tested that before. Kung mas maganda ba si restricted, yung binawasan kaysa kay unrestricted yung kompleto. Okay? Alright. So ito, guys, yung linearity, basahin nyo na lang, i-ano nyo to, madali lang naman to. Last, guys, yung normality. Ang gusto ko lang sabihin dito, guys, kahit na hindi normally distributed yung residuals natin, may ano tayo dyan, may lusot tayo. Basahin nyo to, kasi may mga researchers na nagsasabi na kahit na hindi normally distributed yung residuals, kung malaki yung data set, okay lang yon because of central limit theorem. So may dalawa akong pinakita dito na journals. So wala masyadong problema, guys, sa natin, sa 51, that's above 30. So medyo okay lang tayo. Alright? Okay, so I'll post the exams, guys. Yung unang exam nyo will be due on Saturday afternoon. Tapos yung pangalawa will be due on Monday afternoon. Dalawa yung quiz nyo. Hold ko muna kasi kailangan alam nyo to yung diniscuss natin. Alright, guys, thank you so much for the extension. Ipopost ko na lang kung anong time yung hindi ano yan, guys, hindi required. Parang nagre-record lang ako, tapos kung andun kayo, okay lang. Kung wala, okay lang din. Alright. So, sige, guys, salamat. Thank you so much for, yes, question?
Sir, what time ipopost yung quiz?
Mamayang gabi. Later tonight.
Sir, when will you post the Zoom session?
Hindi nyo yung tinitingnan eh. Yung mga past Zoom sessions, hindi nyo naman pinapanood. Nakita ko, 1 view lang. So, i-post nyo sa announcement kung gusto nyo i-post ko. Kasi, i-ano ko pa sa that's why nga, doon ko sa YouTube dinalagay kasi kung dito lang sa mawawala din eh. So, sabi ko, I might as well post it sa YouTube na lang para lagi nyo ma-access. Pero kung tinitingnan ko yung mga dating sessions naman natin, wala naman tumitingin. So, sabi ko, why will I waste time in posting that to YouTube? Wala naman palang, just message lang sa announcement kung gusto nyong i-post. Otherwise, guys, hindi ko ipopost, Okay?
Yes,
Alright?
sir. Yes, sir.
Sige. Okay,
Sir, yung sa attendance po.
Hindi na ako nag-attendance kanina.
Okay, sir.
Okay, sige. Alright, guys. Bye-bye.
Bye, sir.
Bye-bye.
Thank you.
Bye, sir.
Thanks, sir.
Thank you. Thank you, everyone.